In this lesson, we're going to talk about volume, and specifically volume of right prisms. When determining the volume of any regular shape, and what that means is it's any shape that will look the same no matter where you cut it along its length, you need to multiply the cross-sectional area of the shape with its height. We're going to go into more detail there, but that's in one sentence, one long sentence. Just literally the way to find the volume of any right prism. When we say height, you need to have your wits about you. So height may be the actual height of the object, but as a rule of thumb, it is the length perpendicular to the cross section. I'm just going to use this picture as a bit of an explanation as to what I mean by that. So we've got a cake here, and it's obviously being cut. But you can tell, based on its shape, that anywhere that you would cut in a downwards fashion, you would get the same shape. You get this same shape here, no matter where you cut it, along this way. So even though height we normally are referring to from the bottom to the top, in this case the height would be from this point here to this point here. That's the height, because it is the length perpendicular to the cross section. Perpendicular means at a right angle to. So from here to here, this line here and this line here make a right angle with each other. And that is why this is considered the height, even though it's not the actual height of the cake. So, as I say, this is the most important formula, and we need to make sure you remember this. Remember this. Remember this. The volume is equal to the cross-sectional area times the height. So, just for ease, volume equals AH, and A is the area. So we're going to apply that formula now. So the base area of a triangular prism is 15 meters squared, as you can see here. And the height is 7.2 meters. What is the volume of the triangular prism? So just like we mentioned with the cake, the height is not the actual height of this shape. It is this length here. And the reason why it doesn't actually matter is because it's a shape. You can move it. You can change the way it looks. So let's consider this to be a Toblerone. You can easily just put it on the end and it can stand up. And 7.2 meters would be the height. That is also a massive Toblerone, just so you know. So to solve this, we need, of course, the really important formula, V equals AH. We know the area. We got told it's 15 meters squared, and the height is 7.2 meters. So we just multiply those two numbers together, and we get 108 cubic meters. Okay, so that's it. That's all we need to do when you're given the area. But what if you're not given the area? So in this case, a rectangular prism has a length of 8 centimeters, a breadth of 2 centimeters, and a height of 4 centimeters. Find the volume of the rectangular prism and answer in cubic centimeters. So there's actually quite a lot of ways of approaching this, but we're just going to do it in the way I would consider to be the simplest way. So of course, the volume equals AH. So where your A comes from, where your H comes from, may be different to mine, but we need to make sure we get the same answer. So for this shape, I'm using the cross-sectional area as 8 times 2. So this length times this length. And then we need to times it by the height, which in this case, I've made the actual height, which is 4. And when we add that into the calculator, we just get 64 cubic centimeters, which is, of course, the answer. A tip here as well is no matter what you do with this, whether you consider 8 times 4 being the cross-sectional area, the height would be 2. So you'll notice that each number is only mentioned once. Now in this example, we're going to find the volume of a trapezoidal prism. So the dimensions of a trapezoidal prism are shown in this image. We need to find the volume of this prism. So once again, the formula starts off with volume equals AH. Very important. It's always used. Now, the cross-sectional area is going to be the trapezium, because no matter where you cut this shape in this direction, you'll always get this trapezium here. And the other thing that's a bit confusing is the trapezium formula uses h. So, to make it easier, I've replaced the h, which is for the volume, as a capital H. It's still a bit confusing, I guess, because it's h and h, but I've just tried to make it clear that I'm using two different numbers in these spots. So the area of the trapezium, as we mentioned in previous videos, is h on 2 times a plus b, and then that's the area, and then we need to times it by the height. So in this case, the h, as in the height of the trapezium, is 4. So it's 4 on 2 times a plus b, which is 12 plus 15. And you can do it around the other way. You can do 15 plus 12. It will be the same answer. And now we need to times it by 15, which is the height, as in the perpendicular height to the cross-sectional area. And once we type that into the calculator, we get our answer of 810 cubic meters. And that brings us to the end of finding volume for prisms. Next lesson, we're going to be talking about how to find volume for cylinders and spheres.